Okay, so you build your transformer last time, it's working? Test it if it's working. Yeah, you can adjust yeah, you can. Okay, you can turn it off. Now, in order to achieve to being like a high voltage power supply, right? Yeah. I want to make it a high voltage. Actually, all what I have like 30 volts. That's all what I have on my power supply.
Okay.
Can we switch for 20 to 30 on the power supply?
Yeah.
Yeah? You forget something. You forget your PWM generator. Yeah, let's have a look together. Look what he's saying. 7 to 24 volts. At 30 volts, it will get burned.
Yeah.
Yeah? Good. Fantastic. Fantastic.
We don't want that.
We don't want that. So this lesson, it's so important because
Okay.
it's applying on every power supply from this planet. So it's all about the PWM generator power supply. So how they are doing it? So they are using 220 volts. Yeah.
Yeah.
How they are lowering the voltage from 220 to the PWM generator, required voltage, which usually it's around 10, 12, 15 volts, something like that.
Yeah, but this one is 7 to 24.
This, but normally on the power supplies is not.
Okay.
So how you lower the voltage from 200 volts to 20? Actually, here you'll have like 300 on the if you use like voltage from mains. But in our case, we have like 30 volts, and we have to lower the voltage. How we are lowering the voltage? How you lower the voltage? You lower the current, and the voltage get dropping.
Anyway.
Yeah.
With the resistor.
Yeah.
Yeah.
Yeah. Let's do it. Let's do it. Now you're gonna learn another lesson. Hopefully your finger it will not get burned that badly. But let's use a resistor. Yeah.
Wait a second. Wait a second.
I'm not waiting. No. You said.
Yeah, put the resistor so the resistor will get hot. It will get mad hot.
It depends of the required current. It depends how much current is carrying. But based on this, because this is not taking too much power.
Okay. Then give me a resistor that can carry like
Out of power?
Yes.
Doesn't work like that. That's the idea of this video. Doesn't work like that. Yeah.
Okay.
So let's use a resistor on the beginning. Yeah. Okay. Remove the plus of the PWM generator. Remove the plus wire, and I'll give a resistor. Okay, so we have 330 ohms resistors. Let's power on. It's one and working. Let's check the voltage. What is the voltage there?
20.
20 volts, and it's fine, right?
Yeah.
So we solved the problem. We have 30 volts on the power supply, 24 there, right?
Yeah.
So yeah, it's fixed, right? Touch the resistor.
It's not that bad. It is, but it's not that hot that you cannot touch it.
Yeah, because you have what, 10 volts difference?
Yeah.
Well, boy, if you have here you have 220. On the other side,
Oh.
you're supposed to have 20.
That will melt.
So you see, that's the problem with every power supply from this world. How you supply power to your PWM generator.
So you need something else.
That's the issue. You need low voltage here, not here on the output, yeah, here, and you don't have. You have only the input voltage, which is 220 volts.
Okay.
That's the problem. And when you have 220, and they are using actually more resistors in serial mode because the voltage is high. And when you have SMD resistors, the small ones, you can have spark jumping over the resistors. So let's draw this problem and find out. So what they are doing, yeah, what they are doing. Forget about 20 volts there, yeah. In our case, we have 30 volts, but that's not important, yeah. Let's delete the voltage. So they are using, if you have 220, yeah, they are using many resistors, many, probably like 2, 3, yeah, in the serial mode, but that's only because of the voltage. Because on one side you have 220, and the other side you have low voltage. And if you use a single resistors, you can have like a jump sparking from one side of the resistor to the other. That's the reason why they are using more resistor in the serial mode. That's the only reason. Otherwise, you can use a simple resistor. Like in our case, you are using a simple resistor, yeah?
Yeah.
The problem is, not only your voltage is not stable here, okay? I mean, yeah, probably you can use that Zener diode, and you have like stable voltage. But those resistors, yeah, they are losing a lot of power, a lot of current to get the voltage down from 220 to 20 volts, like what we have, right? And losing current, you'll have a lot of heat.
Yeah.
And your power supply efficiency is going down when you're losing that much power.
True.
So they are using a different method to supply power to the PWM generator. So they are leaving the resistor, which the resistor is used just to start the switching sequence. Yeah?
Okay.
Because if you don't have voltage at all, you cannot have switching, right?
Yeah.
Good. So let's leave the resistors there, yeah? Good. And now let's add a coil over the transformer. Interesting, right? So let's make the core longer. And let's add a coil, but the coil has to be on the same size. Okay, that's not important. Okay, let's add a coil here. So this is another coil. Okay? So what we are doing in this coil, with one wire soldered to ground. Okay?
Okay.
And this wire, how can I bring it there? I'm just thinking, yeah? I will jump here, yeah? Then obviously here it's AC, you need a diode, right? You need a diode, okay? Then, like usual, to smooth, you need a capacitor to ground, yeah? And from here. So what will happen in this case? The resistor, it will supply power in the first seconds, not seconds, milliseconds. They will supply power in the first milliseconds till the moment PWM generator is starting, yeah?
Yeah.
But after that, this coil, it will provide power to your PWM generator. And that's how they are doing it on every power supply. Every high voltage power supply. They are taking power from the transformer to supply power to the PWM generator. So obviously, if you supply voltage from here you will not have a current flow. Or if you have a current flow, it will be very low. But probably you'll not have. Depends of your voltage.
Okay.
What they are using more, yeah, just to make sure the voltage don't goes up. What is this?
Zener diode.
Exactly.
Wait, so they use a diode.
This diode.
Yes.
This is
after-
just to make it from AC to DC.
DC.
Yeah.
Okay, and then use the
Capacitor to smooth
to smooth.
the current.
Yeah.
Then use that Zener to ground to be sure the voltage it will not pass over the Zener diode value. And let's think, yeah, what voltage you have now, like 20 volts, right?
Yeah.
If I come with 21 volts, I will not have a current flow through the resistors. You understand? It will be a current flow just in the first milliseconds till the moment this transformer is starting, and it will provide power to my PWM generator. It's clear?
Yeah.
Let's do it. Can we do it?
We can, yeah.
Because that's how they are doing it. Otherwise, you cannot supply power to the PWM generator. So I redesigned the schematic just for you to be easier. So you can see the extra coil which we have to add it.
Yeah.
Yeah, those two lines means the core. Yeah?
Yeah.
Actually, those coils are sharing the same coil, the same core. Sorry.
So
Yeah?
yeah, so that means that that one should go
Exactly.
in there.
Yeah.
Okay.
So you have a diode, you have capacitor, and also insert a resistor here. Yeah, I want a resistor, 100 ohms resistor, to limit the current through the Zener diode in case you go high on the duty cycle with high voltage. Obviously, the voltage it will rise
Yeah.
across every coil. Yeah. That's what I want to build. That's what I want you to build actually. So you have this wire, yeah? Just add another coil. That's why I told you don't do like a messy work here with the coils.
Ah. So you knew.
Because this is just the beginning on high voltage power supplies.
Okay. So
I'll power off. You try to touch the resistor. You touch it, touch it. Huh?
it's hot, but not that hot.
Yeah, because we have 30 volts.
Yeah.
But if you have 220, it's different story. Okay?
All right. So I should open this one and put another.
Yeah,
Right?
yeah, do it.
Where's the tweezer?
Yeah.
All right. How do I? It doesn't matter, right?
Yeah, but leave the wire longer, yeah?
Yeah.
Because you'll need like that, the wire.
Should I go from?
No. Here.
Oh, okay.
Yeah, just, spin it around. All what is matter to be inside of the core. Count them.
5, 6, 7, more?
Yeah.
8, 9, 10.
Yeah, that's all.
Okay. And close it.
Yeah. Good. So now you have your transformer has actually 3 coils. You can believe that?
All right.
Let's make a little bit of order here, just to be in order. Okay, let's do it. You have everything, yeah?
I have the diode.
Yeah.
I have the capacitor.
Yeah, and the Zener diode.
And the Zener diode.
Yeah, and the resistor.
And this one. No,
No.
this one.
No, that one you leave it there.
Yeah.
This resistor, 100 ohms
Yeah.
resistor.
Which one is it?
And 100 ohms resistor, yeah? Yeah, that's your resistor.
All right. Get back to that screen. Schematic.
Yeah?
So we have the coil, we need the diode, we need the capacitor, we need the resistor, and the Zener diode.
Yeah.
Easy peasy.
Let's do it then. Let's do it.
All right. Wait a second. This one goes to the ground here.
Yeah. Use Rosin.
Good. And this one go
To the diode.
to the diode
Yeah.
here. You know what I want to do, right?
Yeah, take shortcuts. I know.
Shortcuts.
Yeah.
No, I want to do this just a bit to, because I don't have a third hand to. And now, There you go.
Good.
Good.
Yeah.
And then
Yeah, the schematic is here.
this one with this one.
You know what's funny? You'll not learn
Uh,
till the moment you have to desolder to modify the schematic or reuse the components. Yeah. On that moment, you'll understand why you are not supposed to do that.
okay. But I'm all by myself. So it's no one with me to,
Yeah, flux. I'm here. I'm giving you advice.
Yeah.
Yeah. Good.
And this one goes to the resistor.
What? That's what the schematic is telling you?
No. This one goes at here. Sorry. I'm sorry. This one goes here.
Here, what is there?
This is the ground.
Okay, it is.
Wow. Solder one, desolder the other one. What the hell is this?
Yeah. That's called shortcuts. You could use a board, like a breadboard.
This is a shit wire.
It's not like your soldering skill sucks. It's the wire fault, right?
Of course. There you go.
Okay.
Right. Now, this one
Yeah.
goes to here.
Yeah, indeed. Okay, so everything is ready, yeah?
Mm-hmm.
The idea how we can test if it's working. So in order to test if it's working, we have to remove this resistor, yeah? So we are supplying power using this resistor of the PWM generator, yeah?
Mm-hmm.
Good. So if we are starting the PWM generator,
Mm-hmm.
and we are removing this resistor, the PWM generator
We
is still
have-
staying on
Yeah.
because it's taking power from his own transformer.
Mm-hmm.
Cool?
Yeah.
Obviously, if you power off, it's going off totally.
Yeah, because
Because
it's
it has
not,
no power.
No, has
Yeah.
no power. Yeah.
Cool?
Yeah.
The problem is the switching power supply are like this.
Mm.
I mean, they are on and off. They are not adjustable. Yeah.
Okay.
So this kind of supplying power to the PWM generator is not really helpful in our case when we are adjusting the PWM cycle and we are playing with this. But I'm just trying to make the point how the switching power supply drivers are getting power. Yeah.
Yeah.
They are not getting power from the high voltage. They are using the high voltage power just, to get them started, but microseconds or milliseconds till the point the MOSFET starts switching and they are auto supply voltage for their own driver.
Cool.
Huh? So you understand?
Yeah.
That's how every power supply is working. Yeah, has an extra coil, and you will see. We're gonna go through this. That's why I told you, like yesterday, I believe. You remember I told you, yeah? So this is I told you. Here was the high voltage, you remember? And here, those two, I will say, you know what, we're going to learn about those two.
Yeah.
But that's what they are doing. So
Oh,
those
I
two
see.
are doing exactly
Yeah.
what your extra coil is doing. Hmm?
Interesting.
Now let's check this switching power supply. Yeah?
Mm-hmm.
So you have the transformer, and you can see you have 4 pins.
Which one? Those ones.
Yeah, you
Yeah.
have
3.
you have 3 pins.
3 pins.
1 second. No, you have 4. So check here. Here is 1 pin from the transformer, yeah?
Yeah.
So you have 1, 2, 3, 4. Yeah? So 4 pins. Here you have the high voltage coil from here to here. Yeah? Here is ground, and here, what you have here, you have a diode, and yeah, okay, it's 1 pin from the chip. Okay, and you have a diode, and you should have a capacitor. You do have a capacitor there. You have 4 pins because you have 2 coils, 1 high voltage, 1 low voltage. Okay?
Yeah.
That's how they are made.
Nice.
So hopefully everything is clear.
It is.
Okay.